Hi, my name is Corona Wester, and this is my lab video for Lab 2 Lines of Charge for Physics 2 at Georgia Tech. So the skills we focused on this lab was to continue calculating electric fields and electric forces, continue programming in VPython, and using calculus, derivation, and creating derived equations to apply to physics and use for those purposes. So our purpose for this lab was to determine the electric field and force between two pieces of charge tape. Now, our experimental procedures for this lab were very similar to lab number 1. However, the main difference for this lab is that we're not assuming a point charge model like we did in lab 1. Instead, we're using a line model divided into a variable n pieces, and we calculate the electric forces using a derived form of the E-field formula. So using the very similar experimental procedures, the length of tape is 0.195 meters. The mass of tape, assuming 1 gram per meter, is 1.95 times 10 to the negative 4th kilograms. The distance between the tapes when they started floating was about 9 millimeters. And the gravitational force on the tape 1 is mass times gravity, which was 1.913 times 10 to the negative 3rd newtons. Now, the main difference for this lab, like I said before, was using the line model instead of a point charge model. So the main difference was the calculations within the code. So I'll try to skim over the code really quickly and just go into the very important bits. So here we just have our constants, our observed values, and an E-field formula that we developed in lab 0. And this is just the E-field formula straight off the lecture videos. Here we're creating our tape 1 and tape 2 at the bottom. You can see here on lines 53 and 54. This is just creating the picture of our tape 1s and tape 2s. And as you can see towards the end of both of these lines, the n equals value, we can change this to make more or less bits within that tape, to divide it into more or less pieces. Right now we're just going to start with 10 pieces. Here is just some scaling values and some instructions to scale our arrows with later. And here's the very important bit. Here is where we're taking each individual piece of each tape, and we're taking all the top pieces, and I'll go ahead and move on to the next slide to show you. We're going to take each red piece, so we're starting with the leftmost red piece. We're going to see the electric field from each blue piece onto that red piece and sum them all up and get that green arrow. And we're going to do that continuing down the line of red pieces. And then at the end, you can see this white arrow here is the summation of all these green arrows together, which is our kind of our point charge model, whereas these green arrows are more of our line charge model. And as you can see on the bottom, the magnitude of the electric force should still be equal to the magnitude of the gravitational force. So what if we had modeled each of our tapes as a single point charge like in lab 1? Using our point charge model for this set of tapes, we got that Q would equal 1.38 times 10 to the negative 9th coulombs. However, using our line charge model for the same set of tapes, we got 1.24 times 10 to the negative 8 coulombs, which is a whole order of magnitude larger. And as you can see, when I substituted our n value in our code for 30 and broke up the tape into 30 pieces, the magnitude of our electric force actually decreased, which means to make it equal to the magnitude of the gravitational force, this line charge Q value would actually need to be even larger. So why do these estimates differ, and which value is more likely to be closer to the real value? Well, the line charge model is more likely to be closer to the real value because it uses a summation and breaks the tape into smaller and smaller charged pieces. It allows for a closer approximation of charge. If you were to break it into infinitesimally smaller and smaller pieces, you would get a closer value. Because a tape of length long or short is never going to be able to be treated as a point charge, so therefore the point charge formula can only get you so accurate.